Okay, we're given a quadratic function in standard form, and our goal here is to find the domain and range. So the first thing I always like to look for as we're trying to find the domain and range is, does it open up or down? So where I always look for that is what we refer to sometimes as A. It's going to be the stretch or compression out in front. So in this one, because A is positive, we can say that this is going to open up. All right, parabolas that open up have this sort of look going to them. Drawing a quick little diagram of that does help out when you're thinking about domain and range. Next up, what I would probably do is go ahead and look for the vertex. On almost every one of these, we want to be able to identify the vertex. So the vertex in this one, we can kind of look at, it's in standard form, or vertex form, so we can just kind of visualize which direction things have been moved based on how numbers are attached in. So because we have x minus 4/7, that 4/7 is attached directly to x, and we can say that this kind of works the opposite direction we think it should. This is actually going to move everything to the right 4/7 units. And then the 8/11 at the end is being added to the whole thing. We attach numbers directly to the entire function if we're moving everything up or down. Those work in a sense the direction we think they should. So that's going to be moving everything up 8/11 units. So our vertex in this case is going to be moved to the right 4/7, so that's going to be positive 4/7, and then up 8/11, so 8/11 is going to be positive, our y value. Now let's try to answer the question about domain and range. So the domain on this, because it's a quadratic function or a polynomial function, there aren't any restrictions as far as what we're allowed to plug in for our x values. Meaning you may get a restriction if you have a square root or a variable in a denominator, but neither of those happen in this situation. So our domain is going to be all real numbers, or usually we use negative infinity to positive infinity for interval notation, but this means the same thing as all real numbers are allowed to be plugged in here. Sometimes we'll see this notation meaning the same thing as all real numbers, or negative infinity to positive infinity. Next up, our range. And this can be a little bit more tricky, but this is why we identified the opens up or opens down at the beginning. The very lowest point on this graph is going to be where our vertex is, or the very lowest y value is going to be 8/11. So everything's up from there. So what we can say is it goes from 8/11, and then it goes just up from there. So that goes up to infinity with no restriction. You can never get to infinity, so we're going to use an open bracket on that side. But the vertex is actually a point on our graph. So it's going to be included, so we use the closed brackets on this side. All right, hope this helps as you're trying to find the domain and range of a quadratic function. When you're in standard form, I always like to identify the vertex by visualizing transformations. If this happened to be in general form or the expanded out version, I would use our formula negative b over 2a to help me get the x value, plug it back into the function to get the y value, then you have your vertex, and the rest is very similar. All right, hope this helps. Good luck.